Welcome back, ladies and gentlemen. Today is section 10.7, and this is the cool stuff. This is where we take a circle and we put it on the coordinate plane, and you're going to be able to give me an equation for a circle by the end of the day. Cool stuff. Up on the screen, you will see your exit question for the day. All right, here's the big connection that we're going to make between geometry and algebra. Okay, we're going to apply numbers to every single part of the circle. I can have you set up and solve an equation to find any coordinate along the circle anywhere. So here it goes. Here's a circle placed on a coordinate plane. Put a point on it, right there. Its coordinates are x, y, for some x and y. Now this circle has a radius of r, and now that it has coordinates, you can draw a right triangle connecting them all, just like that. So the radius is the hypotenuse, the x-coordinate and the y-coordinate are the legs of that triangle. And because of that, we can use good old Pythagorean theorem, or if you prefer, the distance formula with the origin to relate all three variables together, the radius to the x and y coordinates. And it would look something like that. And this right here is the standard form equation for a circle. Now, you'll notice that this isn't very graphable because it is not solved for y, but this does represent all of the points on the circle at any coordinate x, y with a radius of r. That's your major information today. You'll notice that this equation looks a little bit different, and I'm going to talk a lot about it later, but this is the big one today. Anytime you're asked for an equation, you're going to plug in what you know into this equation. You'll notice that there's an x-coordinate, a y-coordinate, and then there are three items that you need to produce. So just like the y equals mx plus b equation for linear equations where you had to come up with a slope and an intercept, for a circle you have to come up with the location of a center, which is given by h and k. H is the x-coordinate of the center, k is the y-coordinate of the center, and you need to come up with a radius. Really not that tough. All you need to come up with is a location for the center and a radius, and just plug the numbers in. Okay. Now, like I said before, this isn't very usable, nor is it very obvious to the reader. Well, this one is pretty obvious to the reader how big the circle is and where is it located. But if we solve for r, so pretend the radius of this circle was, say, 7. If you were to look at this equation and the radius was 7, the right-hand side of this equation would say 49. And that is pretty easy to know what the radius of the circle is if you know what you're dealing with. But it's not just a direct answer, here's the radius, here's the center. So a lot of the times this same equation is simply solved for r. So the square root is taken of each side. And that way we can see very clearly just by glancing at the equation, the x-coordinate of the center is h, the y-coordinate of the center is k, and whatever this number is, that's my radius. So I can very clearly see those three things, so I can very quickly go ahead and graph the circle. Now, like I said, this is not very usable in terms of graphing. If you plug this into the graphing calculator, both your variables are on the right or the left-hand side of the equation. Doesn't help you at all. This y and this x are seemingly buried in here, and it does take some work and some rearranging, but now that you've gone through some quadratic solving and those wonderful physical science equation solving problems, you can probably solve this equation for y. Give it a shot if you're bored. Otherwise, just hang on a half a second while I click this screen here. Boom, here it is. So if you take this equation and you solve it for y, you have to subtract this whole term over here. So that's where we get the I squared minus x minus h squared. And then you'll have this subtract k left over and this whole term is squared. So you have to take the square root of both terms over here. That will result in a positive and negative version of it. And then you have to add a k to it. So it's k plus or minus the square root of all this. And this is how you graph something on a calculator. If you want to graph a circle on a calculator in XY coordinate plane, this is how you do it. But you have to do two versions of it, a positive version and a negative version. The positive will graph the top half of the circle, and the negative version will graph the bottom of the circle. Hey, let's take a look at this in Sketchpad. Over here, I have a manipulative of all the things. So here is the center of our circle. Our center of the circle right now is centered at the origin, 0, 0. Here's my radius. And here's the equation that we're plugging it into. And these are the two functions that I've plotted. Okay, so these are each the situations where the equation has been solved for y. And you'll notice that one has a negative in front of it and one does not. So this is the top half of the circle and this is the bottom half of the circle. And I can prove that to you if I were to change some of the numbers, and you could see a shift between the top half of the circle and the bottom half of the circle. But we're not here to do that. We're here to play with these slide bars. These slide bars control the radius. So you can see if I increase the radius, that would be this number right here being increased, or in this equation, this number right there being increased. And I can simply slide bar that and it makes the circle bigger or smaller. Then the other thing we can do is we can change h and we can change k together or separate. If I change k, this will do a vertical translation of the circle. And if I change h, it'll be a horizontal translation of the circle. So by just altering these three values, you can place a circle anywhere you want it with a radius of any size that you want. And that's basically what your example problems are here to deal with today. Simply writing equations for circles that you have information about or you're given a picture of. So the first one is write an equation for a circle with center at 0, 0 and a radius of 12. Pause the video and see if you can pop the numbers into the right place. Substituting into the equation, you put a 0 in for h and k, because that's your center, and your radius is 12, so you pop it in right there. A little bit of simplifying is in order, so we get x squared plus y squared equals 144. You do not need to take it any further than that. You're done. The next one's slightly more complicated. We're going to take a circle and shift it so that its center is at -2, 5. Again, just substitute in the numbers. Notice that we had a double negative cancel out to turn into a plus, and otherwise it's good to go. Now, you might be tempted, and I won't say this very often, but you might be tempted to FOIL these. Don't FOIL these, okay? Leave it as is. The reason being is that someone can look at this equation and very quickly figure out that the center is at -2, 5. That should be a 5 right there. Sorry. Typo. There it is. It's probably going to be wrong in the next slide too. And then the radius is 3. Now, generally speaking, we don't let the 3 squared stand. We do change that to a 9, and yep, there it is on the next slide again. But we're going to live with that. We're going to pretend that this is a 5. It is a 5. Look at that. Done. 5. And then it's correct. So you don't need to FOIL these. Generally speaking, we either go ahead and square that number or we put a radical over the entire thing. Either one is totally acceptable. You can still consider it to be in standard form. Next example. I'm going to preface this example with you totally don't need this picture over to the right hand side to do this problem. It's handy because it's a visual aid, but be prepared to do a problem like this where it says write the equation of the circle and you're only given the text, okay, not the picture. So the way we do this is the point -5, 6 is on a circle with a center of -1, 3. The immediate information that you get off of here is you have an h and a k value. So you know that right away. The only thing that you don't have is a radius. Now the cool thing about a circle is every point on the circle is equidistant from the center. So if we can just calculate the distance between these 2 points, we have the distance from any point to the center, giving us our radius. So if we didn't have the picture sitting right over here, we would just do a distance formula calculation on that. But since we do have a picture over here, we can draw a triangle in there like that. And it just so happens that, again, hey, it's a 3, 4, 5 right triangle, so the radius is 5. And from there, all you have to do is pop the numbers into the formula, square the right-hand side, or draw the radical over to the left, your choice. Up on the screen, you'll see your homework. We're doing a worksheet tomorrow. I will see you later.